Okay, today we're going to go through your scientific method, and I had given you an advanced organizer on the previous page that looks something like what you see in front of you. And we're going to go through and fill in some of those blanks. I left some parentheses there that we'll do together. And throughout this explanation, I'm going to give you an analogy of an experiment, kind of a fun experiment based on something I'm interested in, that you could use to apply some of these, so we're not just looking at definitions for each of these parts of the scientific method. So as with any scientific experiment, basically you have to start out with a question. So the question is something that you're curious about, okay? Something you're curious about that seems like it would be testable, okay? So we could write in here, so a curiosity that is testable. Again, and we'll go over this several times, but testable means that it needs to be objectively measured, which means it can't be somebody's opinion. It can't be, you know, what flavor of popcorn do people like best, because that's complete opinion. There's no way to measure that. It should be something that you should be able to assign a number to. You can weigh it, you can time it, you can measure the distance, something along those lines. All right, so that's our question. So any good scientific experiment starts with a question. The hypothesis is your answer. So put in here my answer to the question. So you've probably heard before educated guess, that's fine, but it's your way to answer the question itself, okay? And I'm going to even put here at the end, with reason. You should have some educated guess and a reason for it, okay? Not just, I think that it will be 12 meters. Okay? Why do you think that? All right, then we get into variables. So you have two types of variables. You have independent and dependent variables. So the independent variable is the thing in the experiment you are changing. And I'm going to even put intentionally. Intentionally changing. So, for example, in this experiment, I'm going to give you an example of something that I want to do with some mountain bike tires. So let's say that I have a question, and I want to know basically what brand or model of mountain bike tires are the fastest. And so I could set up an experiment to test this. This isn't something that you would necessarily do in a lab. Not everything that you test using the scientific method, you're even going to necessarily know that you're testing. Sometimes you use portions of the scientific method when you are deciding how to buy a new flat screen TV. You compare different TVs and you use some of these methods, at least parts of them, to come up with an answer for yourself. Which one do you want to buy? Okay, so in this experiment, I'm going to say, all right, I have two brands of mountain bike tires, and I want to see which one's fastest on a given course. So I'd have to pick my course to begin with, pick my mountain bike tires, and so in this experiment, the independent variable would be the brand of mountain bike tires. So basically what I would do is I would pick a course, I would go out and ride that course on one set of tires, and then I would ride it on another set of tires, and I would compare the time that it took me to do the course each time. And if one of them takes less time, then I could draw a conclusion that possibly those mountain bike tires are faster. Okay? So the independent variable is the thing in the experiment you are intentionally changing. The dependent variable is the result of changing this independent variable. It sounds a little confusing, but it's not that bad. So result of changing, I'm just going to put ID for independent variable. So what can happen when I change the mountain bike tires? I go and do one loop on a course on the first mountain bike tires. I write down my time, and then I go do another loop on the course with the different mountain bike tires, and I write down my time. You basically, in this situation, have three options. The time can be faster, slower, or the same. So your dependent variable is the result. The time it takes can increase, decrease, or stay the same. You hopefully want one of those times to be lower than the other. Okay? If they're identical, then you might be able to conclude that there is no difference between the two as far as speed goes. Materials list or diagram, pretty straightforward. And I put diagram here because I think it's applicable many times in scientific experiments to just draw all of the materials you're using, especially if you have some sort of setup. So we'll put here stuff I need to do the experiment. Stuff I need to do experiment. Pretty straightforward. Again, list or diagram. Either of those is fine. So, scroll down here. I know this messes you up a little bit. But what I'll do is just erase these. Slow eraser. Okay, so now we're into identifying control and constant. So control in an experiment is the thing we will compare to. And the constants are all the things that must stay the same. So the control can get a little tricky. So every scientific experiment you're doing is not going to be blatantly obvious in identifying all of these components. So the control in my mountain bike example is a little more difficult. So in that situation, essentially the control is the other set of mountain bike tires. So if we call the mountain bike tires A and B, so when I ride A, I am comparing them to B. When I ride B, I am comparing them to A. So the control shifts a little bit. I could go out and ride a third set of tires that, let's say, I know possibly are significantly slower. Maybe they're a lot heavier, maybe they're too worn down, something along those lines. But really, a lot of times you're comparing the results of two different things. So you're comparing A to B and B to A. Okay? The constants, this is really important, are all the things that must stay the same. So in my mountain bike example, the only thing I should change is the mountain bike tires. I need to ride the same course on the same bike. I need to make sure that I eat the same thing. If I'm going to do it 2 different days, which would probably be wise, I need to make sure the weather's the same. Okay? If it rains one day and it's dry another, that's going to change the course conditions. Okay? I need to make sure I get the same amount of sleep. I need to make sure that I start at the same time of day, so the sun's in the same place. All of those are the constants. Everything else in the experiment needs to be the same, except for one thing, which is my independent variable, which is the brand of mountain bike tire. I want to repeat the exact same experiment exactly the same way, once with tire A and then again with tire B. So if I see a difference, I know the only thing it can be attributed to is the difference in tires. All right, experiment or procedure, this is pretty simple. This is where you explain what I'm going to do. And for those of you that don't like to write, you're going to like science a little bit more. A lot of times you are going to write bulleted lists. In this case, think about this like a recipe. When you read a recipe to make banana bread or mac and cheese or whatever it is you're cooking, it gives you very brief statements. Step 1, add 2 cups of milk. Step 2, stir in flour. Step 3, add cheese packet, whatever that is. Okay? So in our experiment here, I just give very brief but descriptive, they do need to be descriptive, very brief but descriptive steps, and you will need quite a few of them. You need to set up your experiment or procedure in a way that you could hand this to someone else, walk away, and they could conduct the entire experiment without having to ask you 57 questions. Okay? Do not leave things out, do not make assumptions. Okay? So again, lots of steps here, bullet points, ABC, however you'd like to set that up. Data collection is just where you record what you observe. that usually tables and charts, because we're usually dealing with numbers, but a table or chart would be appropriate there. And then, excuse me, results. Now, specifically, I want you to include in your answer, did your experiment support, I want these terms, or not support? Your hypothesis. I'm just going to put H because I ran out of space. So I don't want you to necessarily say that, hey, my hypothesis was right or my hypothesis was wrong. Okay? Because a good scientific experiment would be conducted multiple times. Again, back to my mountain bike example, if I wanted to do that, I really should go out and do that experiment 3, 4, 5, 6 times. Over and over again, tire A versus tire B, tire A versus tire B, and compare those results over time, maybe average them. Sometimes in experiments we call those trials, trial 1, trial 2, trial 3. Okay? That's about all you need to fill in, but I will go over the rest of this real quick just because it's there. You can read this. Think of the things in red as a checklist. Okay? So for results, this is, those of you that don't like writing, unfortunately, this is the part where you do actually have to write a paragraph. Okay? So usually around 5 to 10 sentences. So if you look at that, you have 1 sentence to review or restate the question. On Saturday, I did an experiment to test which type of mountain bike tires are faster. Boom, I just restated my question. Part 2, review or restate the hypothesis. Again, only 1 sentence. My hypothesis was that tire B would be faster because of the lower profile tread. Let's see, so far I'm only at 2 sentences. Summarize the experiments next, including actual results, 3 to 6 sentences. Okay? So that's where you would go through and summarize. You would summarize the experiment or procedure. Do not write all the steps again, but just a summary of what you did to test it and then what results you recorded in your data collection. Okay? And then state whether the experiment supported or did not support your hypothesis. Okay? And then the conclusion, you can see, must answer the original question and must use all of the available data.